back to another PlayBASIC Live impromptu video actually. Today I want to talk about this media index question. Probably a left of field thing to come up with. I'm looking at the guts of PB, trying to make sure our pattern is the best it can be for what we have. And this has bothered me for quite a while. You mightn't realise this, but potentially you can have 2 to the power of 32 unique media indexes for the different command sets. So any command set that allows you to create different types, different characters or different objects. I'll try not to use the word object. So for example, if you're using sprites, you can use the create sprite and use the index 1 to fill up that slot, slot 1, or you might use index 100 or 2000 or 4000 or 25,000 or 65 million or something like that. Now, to support that, we need to have these big tables underneath. There's this just giant buffer. That's really what all there is. And that's okay, but if the table has to be resized or anything needs to be done to that, in other words, if you fill up the table and then, either set the quantity of that media. So, for example, with sprites, you can tell it to expand the internal table of sprites by using the sprite quantity command. In case you didn't know, and all the command sets have a variation of this. So if you're talking about banks, there's a bank quantity command, there's an image quantity command, and so the image quantity command is the same thing. Internally, there's probably a set number of the image tables are probably set up for about 1,000 images when the app starts. If you need more than that, you can just use the image quantity command to expand the table, and then you can use indexes beyond that base 1,000. So 2,000, 3,000, however big you set the table. But the bigger you do that, it's a big chunk of memory that's been taken up. Now, there's other reasons that's kind of bad. It means that if we have 2 different threads, so we try and split apart a bit of code from the main PlayBASIC thread and do it in the background to hide the time that takes away from the user. A classic one is like loading an image. If we have a function that loads an image in a background thread, and you try and either create another image while it's doing that in the background, and the tables need to be resized at some point, or that data needs to be written to or read from for some reason, that's a crash waiting to happen. Now, look, I can solve those problems, but you end up with this kind of contingency problem too, where one thread owns the data for a certain period of time. When it's done with it, it says release. This kind of check-in, check-out mentality. If you do that with just having 2 threads, for example, imagine you've got 2 programs running. That's probably a better way of putting it. You've got 2 programs running, but they're both feeding off the same piece of data. And program A says, I've got access to it now. I lock this resource from program B. Now, program B can't do anything until it's allowed to access this other piece of data. So we've got 2 threads, but we aren't doing 2 things at the same time. So ideally, what I want to do is I want to have a simple mechanism that allows us to safely load something in the background, whether it's an image or some data from memory or whatever it happens to be, without these really basic, these primitive sort of problems where the index table is being modified. And secondarily, what I wanted to do is store the index tables in a more elaborate fashion. To test this theory out, I've written a bit of a class and come up with an alternate version of the banks library, right? So each bank at the moment just has a media index, a size and a buffer. That's all it has. I think we actually have more in the old PB libraries, because there's other things banks could do. I can't remember what they are off the top of my head, so I left them out. I've got an open library, a closed library. They're just placeholders for the time being. They don't do anything. But our functions are just like, PB functions. PB create bank, we've got a media index, the size of this thing here, we make sure it's here. We can't report errors back to the VM in this version. I haven't got that included, pretty much. There's a kind of a handshake that needs to happen, which is what would happen when this open library is called. Because we're not calling it, we can't get the function pointers to set an error status or that kind of stuff on the runtime side. That lets us decouple our libraries from the engine, which is how it's done for the other things as well. Anyway, so we've got a really simple library. We make sure our size, readable size, we just check if it exists. In theory, we should either delete it if it's a very different size than what we already have, which would make it a better solution than what we currently have. Let's say you're recreating a bank, but you want it to be, let's say a bank was, 10K long, 10,000 bytes long, nice round number. And then we recreate the same media index, but we say we want it to be 10 bytes shorter than what it was before. Now, there's no point deallocating that old buffer and then allocating a new buffer if we can just reuse the existing one, and the wasted memory isn't that great. So that's what we'll just do. It's just not implemented. Didn't bother. Of course, didn't bother to, I'm hacking it together. A delete bank function, of course, we're just going, give us a pointer to this bank, to this media index, this bank. If it exists, free it. If it does, clean up the buffer and we're all happy. Delete all banks is a bit more of a verbose than the delete, but it just wraps this delete function, as you kind of would expect. So if we have for example, what you normally see in these command sets is that you'll see this kind of thing here, that create bank before, and this would be a function in here for doing new bank, PB new bank, and so in here we'll have here, and this will call pretty much get get bank free, which isn't defined actually. Oh, sorry, it is defined, but it's not defined so we can see it from here, so it's not telling us. And that would just then do this. We'll just go PB create bank, media index, and the size. So those secondary commands are very tiny, small wrappers pretty much for existing functions. Sometimes that's not the case. In some other libraries I can think of that actually are quite verbose, because they needed to be as quick as possible. But for things like banks and files and that kind of stuff, they're not a massive concern. That won't compile at the moment, so I'll get rid of that. Anyway, delete function, delete all here. The status requirements, get the size of the bank, get a pointer to it in memory, get a free bank there as well. We've got the peek and poke functions. We haven't got strings included for much the same reason. We need to get access to the internal string libraries rather than have recreations of those libraries inside every command set you write. Just crazy. There is a problem with doing that, because PB uses an internal pool again for internal allocations, and this allocation pool can be resized. See, with strings, there's a potential issue with threading in particular. So, like for example, if we have a function that does a copy memory function inside one bank to another, since we talk about banks, what we ideally do is have a lock on the source and target, push this off to our jobs thread, and then return. So to the user, it seems like the copy was very quick, but the copy is being done in the background. So we need some sort of identifier to tell us later on that that job has been done. How that mechanism will work, I mean, who knows? Who knows at this point? Let's head across to PB itself. So one of the reasons for doing this stuff is I know that internally when we have these media indexes, we have these big range of media indexes, they're expanded and contracted a lot. The Sprite one does this quite a bit. In here, the table is expanding chunk by chunk, but it's not actually being resized and touched after they've been allocated. So it's safer. This is plugged into this GUI test from the Math64 library, so it's the same test. Go to console, hit the banks thing at the bottom. It gives us some information about the output of this particular function here. So we're running through and we're creating a bank every time we update the screen, and then we're filling this bank full of bytes. The code itself is just running through. We've got a side-by-side comparison against the internal commands against these imposter commands, and these are just linked into PB via link DLL. That's why I'm using this framework. It's got the menu system set up, etc. And just I can literally just chuck it in and run it, and I don't have to do anything with it. I'm that lazy, yeah. Of course, I'll pick the code out and separate it off later, but what we would need in this link DLL block, which is, if you're not familiar with this stuff, it's kind of setting up, we're telling PB that this is a bunch of function headers, and these are parameters if there are any parameters. So it uses the variable name here and the type of the variable to infer what kind of parameter this is going to be. The name we use out here can be different than the name inside the library, inside the DLL. In this case, they're not. So we probably could get away with doing that, actually. And then we have a return type on the end. Not the most elegant of solutions, but syntactical declarations. So when PB runs through, it looks through this block and phrases these things out and goes, adds this to the function table, and builds this parameter list for it, understands that this is the actual DLL it's calling, the function it's calling from this parent DLL. What we would need to make this work pretty much the way internal command sets work is that we need this startup function, whatever that was called. Where is it? Oh, there it is, open library. Has no parameters, so we have a function up in here. PB has no parameters. It's aliasing. Now, when these headers, these names are exported from C, they're normally mangled, but you can tell it not to mangle it. It puts the parameter list. That's what the number is at the end, actually. I've always used this approach. Because it's not returning anything, we just have a library like that. Now, we probably have to tell PB that this is the initialization function for this particular command set. And once we hit exit from our program, once we stop user execution and have to close down the runtime, we need to close these command sets because they might be allocating all kinds of weird stuff and need to be cleaned up before we exit back to Windows, pretty much. So we have some sort of close, and now I guess we could just have a standard name for these things. So each DLL has an initialization for opening and closing its command set. So that would do things like it would get the internal pointers to common functions that third-party DLLs are going to need to use, third-party command sets will need to use, like dealing with strings and dealing with files and dealing with some of the more sort of straight-ahead memory management stuff that some things will need. In some cases, there's like math functions and that kind of stuff. Although I guess that's less. They tend to be used, like the math libraries in particular, tend to be used in certain areas, like in the sprite libraries or shape libraries, for example, like rotations and intersections and that kind of stuff. So I hope we're making some sense here. So this whole conversation about indexes is about storing this data, having command sets, allowing us to detach them from PB, but still have them be declared in a way that makes sense in a human sense. But we need a secondary way. We need a bit more what we have at the moment to cover this. At the moment, when we run this example, we're not really cleaning up properly, because this cleanup function here has never been called. It doesn't even exist in the library at all. As you can see, there's no code in that whatsoever. It's just a stub, pretty much. So we've got this thing sort of set up. Performance-wise, in the comparison test before, we are getting a good benefit from this. There's the bank test one here. So our simulation of the bank commands are running almost 3 times faster than the internal command set. Now, some of that I think is because the way this function calling here works for external linked DLLs is better in 165. I think that's probably where most of that comes from, and other parts are actually the way it's set up now is probably a bit more efficient. We do have some secondary things. Rather than just this index mapping stuff, we actually have management of the structures better. So let's say you have 1,000 sprites, or your quantity of 1,000 sprites, and internally what this is doing is it's breaking up that 1,000 into subsets of, let's say, 256. So we have 4 blocks to represent, so if I'm writing to sprite 300, that's in the second bank of these sprites, these sprite structures. Now, what old PB does, has a huge table. If you're comparing sprite 1 to sprite 1000, they're a long distance apart in actual memory. They're a huge distance apart, actually. What the new one does is it tries to put, every time we create a sprite, it tries to allocate that data on its little internal heap at the top of the heap. And we're trying to do that because we want to make sure that this data is near each other. And the closer this data is, that means we get benefits from your CPU's caching abilities, primarily, pretty much. In fact, it runs much better like that than it does any other way. Whereas that doesn't work in the old version. So if you use indexes that were a long way away from each other, it's detrimental to performance. Now, there is an issue with doing this, is that since the index ranges are broken up into, let's say we have our 1024 block of sprite indexes that are available to us. We have 4 blocks that cut down the chunks. So if we only use sprites in the first 100 and sprites in the last 100, then the blocks 2 and 3 in the middle, they're not used at all. So we're saving memory there. And if we add new chunks, the sprites in position in the low chunk and the high chunk don't need to be reallocated, moved, etc. All of that junk. So we're saving ourselves time from that regard. But if we're comparing two sprites that are in different chunks, we have the same basic problem. So if we're comparing a sprite that's 100 against sprite 900, they're in two different chunks of memory. I think I can manage that a bit better than what's done at the moment, and that would help with that caching down the line. If you think caching is not important, in existing PB command sets, there's a lot of contention about how they access memory, when they do it. The way it was written for how it's written, it's not, it's okay. It's not the best way, but it's okay. It served a purpose. I just don't want to build this stuff onto a basis that has the same basic faults. That's why I kind of sound obsessive compulsive about this crap. It is crap, and it will do your head in. But to get things that are more in a state where we can actually bring threading to the table, at least at some point, the idea of you having to load a big file into your application and not being able to thread this in the background is kind of mental. We should be able to do that in this day and age, and we should be able to do that in a safe way, and not have to tax, not put the barrier to entry so high that people just don't understand how to use threading. Like, we've already got some threaded queued stuff, this kind of threaded heap stuff for some of the graphics rendering stuff, but there's very specific purpose. The idea there is you tell it to use threads, and then you tell it what big render jobs you want done out of a handful of render jobs. And then once you've queued them all up, you tell it to draw this stuff in the background while you sit around and do other stuff while it does that. If you're sitting there and waiting for the secondary thread to complete, you're just wasting time. You need to be doing something different while it's doing its job. The point I was trying to make is that we want to have a mechanism that's kind of simple for people to use and safe for the command sets to function. So we can get a job that requires a lot of work that we would normally have to wait in a linear fashion. We would normally, a classic one is the load image command, for example. You tell it, hey, load this image into memory, and it runs off, grabs it off disk, decodes this thing, creates a surface, and you have to wait until that thing's finished. Now, it might only take 100 milliseconds to do that, but if you're making a game and you want to load media as the game is running, that's a problem, So if we could have something where we could say, hey, load this media in the background, let me keep updating, and then tell me when it's finished. Tell me when that image is ready for me to use, and I'll display it for the user in the character, in the game. Like, imagine if you're playing a shoot 'em up game and you're coming up to the big boss, and rather than load all of the media up front, make the user wait a minute, 2 minutes, 5 minutes, who knows, depends on the size of your graphics, I guess. What if we just loaded the content we need for the current screen and then the screen we're moving on to? Think of it in a game like R-Type or that kind of thing, where we're scrolling along at a fixed rate. We don't have to have the entire level in memory at once. We don't need it. As we need new character types, we grab them off our storage device. We set up a thread to load in the animation in the background. And we do this, probably, maybe 10 seconds before we need it, just to make sure it's loaded comfortably, with no contention issues happening with it, so we can do it. Somehow we got sidetracked from our internal command sets here. One getting back to our index conversation, sorry about getting sidetracked a lot. We have found one problem is that we've got a good improvement with our simulation bank command sets versus the internal bank command sets. They're 3 times faster, or 2.9 times faster. There's one issue, which is to do with grabbing a free index. So you might be familiar with these variations of PB media commands, like, since we're talking banks, we're talking about the get free bank, which you call it and it just gives you an index that's currently not in use. Now, internally it works there's a linked list mechanism behind the cells. Now, in a new media indexing caching solution, which is much more complicated than what we had before, we don't have a linked list. So to find a free index, we have to look for some identifiers inside the banks and then do a search. Now, searching is pretty ugly. It's linear, in fact. So the results for our performance test here were pretty terrible. This version here, which is, I've actually sped up a bit since then, this one is 64 times slower than the old get free bank, but that's to do 500,000 tests. So yeah, let's put that into perspective. In this case here, we're costing ourselves almost an entire second. So that linear task needs to be optimized away. For banks, it's probably not a big deal, but for sprites, where you are creating and destroying sprites a lot per frame, that could see some detrimental overhead for our application. So it's, I'm keen not to introduce. There's no point of speeding up one aspect over here and then going, well, this other aspect that you use just as much is now even worse. That seems silly to me. I thought about this afternoon, so I posted this this afternoon, was it? And thought about it a bit more when I was out today. I think I'll have to introduce the linking of the cells internally as well. It'll be different from how the old version works. It's a bit more complicated, but we should get to a point where our new system, we can grab free items from free media indexes at pretty much the same speed, possibly a little slower than the old one. But I'm hoping to get this to a point where it's, maybe it's 5% slower than what it used to be. That would be a great win, because if it's 5% slower and we're making gains of 10%, 5% in other places to do individual tasks, given we're only calling these get free items once, but to do things like manipulating a sprite or writing data to a bank, we're doing lots of peeks and pokes, which all access through that media index mechanism. The fact that it's 2.9 times faster doing that, we're quite comfortably compensated. That's the hope. May not be. Can't guarantee those things, but I hope so anyway. And this will translate across to all command sets. I'm going to have to remake the whole sprite command set. I've got 3 different versions of that, I think there is, which is kind of crazy when I think about it. I need to have a better look at how we're going to separate the driver from the background, so we can have different interfaces behind. We can use either a GDI render or OpenGL or a DirectX at some point. If we just go OpenGL, that gives us a straight transferable platform. That's what everyone else does. Why not do it? I have been looking at one solution that I did like the look of, which is a middleware solution, which actually comes as a bunch of libraries pretty much that do a lot of the cross-platform Surface stuff for us. and we just get a surface, we go, hey, we blast our images onto it just with OpenGL. But it also handles the platform stuff behind it. And it seemed pretty lean, which I like the idea of as well. So it's not a huge library. It doesn't not going to bloat things out too much. And we can get, well, ideally we can get the stuff to build on just Linux would be nice for starters, and then on a Mac, and then if you can do that, you can get it to Android. That's pretty much covers what I wanted to get through today. I haven't been doing much lately with videos, etc., because I've pretty much had a lot of work with my caring role. In fact, my mum was quite ill there for a few weeks. We're in and out of hospital, etc. There's a whole bunch, which is fine now. It's all academic, but which is as fine as what she'll ever be. But when that stuff kicks in, you realise just how little time you actually do have. So to do this stuff in blocks like I've been doing it, it's possible. I've got to be very focused about what I'm doing and what I put my attention to. You'll probably see more weird questions coming out at you in time go by. I'm sort of feeling out what people are, what's important to people. I have a list of things that are important to me that I think PB has to solve that no one else has done. A few I think are incredibly imperative that no one's even bothered to tackle yet. So whether we can or not, whether we can get to those things, I have no idea. But it all starts with these basic building blocks. Getting these building blocks into a way we can actually have pluggable command sets would be a huge step. That means that a lot of the pressure's off my shoulders. There is a problem which I haven't addressed actually. One of the dramas with the way PB works. Yeah, we'll just fantastic bit of code, sync, white key. We'll have an array up here on a dim table. 1000. If I create bank 1, and I want this thing to be 20,000 bytes in size. Hit F7 to run debug mode. The program's sitting in a wait state because it's got to this point here. So I hit stop to tell it to stop. Go across the variables. A table exists, and I can't view the contents of the bank commands. Now, this is something I always wanted to implement in the state side. Now, if I pull out the internal bank commands, right? So here we've got a bit of a general overview about how many banks are being used, this is that quantity value I was talking about before. This value here represents the quantity of the media resource. So banks by default have 1024 when the runtime starts. Cameras have 16 available. Files have 64. Fonts have 64. Images have 1500. Shapes have 500, which is kind of an odd number. Sprites 1500. Maps 128. If I pull out the internal bank commands, the debugger wouldn't be able, we wouldn't have this kind of information about the internal commands. We have like a third-party command set. We would need, as we're talking about having the open and close function, we would need functions that the debugger can call back into and get information about this thing. You can view the memory consumption of PB programs when in debug mode. So when I've created this bank before, and it gives us the size and a pointer to where this bank is in memory, and an overview of how much it thinks the bank library is consuming of memory. At the bottom, it gives you a bit of an estimate of what this is going to be. So 3 megabytes, 0 megabytes, it's less than a meg. So it's obviously not bothering to round them up. Small problem there. My point being is that you mightn't use this, but I find that very useful, right? And I can think of things in the debugger that would be really useful to have in a debugger. And if you had external command sets, we couldn't kind of do that in some easy way. We would need to have the debugger have less access to these commands. The way this works, by the way, is that this bit of text here is, it just calls the internal command sets about banks. What's the current bank quantity? What's the camera quantity? How many files are in use? You know, it gives you an idea of. Actually, it's kind of interesting. It's saying there's no banks in use. Yeah, they might be broken. We might have found something else that's broken. We're running 165 here. It's, you know, that itself has been an unbelievable amount of just head bashing. Trying to pick it up here and there and get it running is not nice. The guts of this is so complicated now, overly complicated. Like a lot of things have been simplified away, but it's still probably too complicated for what it does. Still. Getting back to my point before, is that if we wanted to have these kind of continually or even better ideas, like I'd love to have an image viewer tab. That would be fantastic. Go across and view an image, you know, have a hover ability over a code view. That kind of stuff would be my basic wish, really. It would have to be pretty robust, but you know. So at the moment, I can't think of a way that if we externalize all these command sets, you wouldn't be able to get this information. You would have no idea of what this stuff is. Like, it wouldn't know what the current font is, what the scene data is. It couldn't get those things. They would be in libraries that it doesn't even know exist. Yeah. So it's going to be a bumbling problem to solve. It might take a few iterations to work out a solution for that. That's convenient for both sides of the equation. Anyway, that will have to do us. Sorry about this mumbling sort of chit chat today. I just want to make sure I got something out there about what I'm trying to get to with this stuff here. And if I can get this to our Banks library to be a like-for-like replacement, I'll try and chop out the old bank command sets and go, here you go, here's our new ones. Let's see how, let's try it in the field, you know. I can see it's going to blow off my face already, but you know, we might as well do these things. Until then, thanks for listening, thanks for hanging around, and jump on these threads here and have a look at them, and you know, get stuck into some of these weird questions that might be coming your way in the future. You know, get stuck into these weird other projects I've been posting over the last year in particular. Got a pretty good collection of weird projects for the last 12 months, I think. If you want to have a bit of a go at the PB effects core, the old core, which was written about 12 years ago or something, 10 years ago, I have no idea. It's pretty ugly. It's not really meant for production use or use by people. It's sort of me fiddling around with how it could be set up internally. So there's not many commands in it, but trying to decouple the requirement, the internal requirements of it. It's trickier because you're trying to make this thing efficient, but you're trying to make it simple, and they don't always go together. That will definitely have to do us. Thanks for watching, and I'll see you next time. Bye.